Bismillah ar-Rahman ar-Rahim. We'll start now with the first subject in this course. The first subject will be waves. There are three types of waves actually. There are what we call mechanical waves, there are electromagnetic waves, and matter waves. But first we have to know what is a wave. A wave actually is a motion of a disturbance. So you make a disturbance, and the motion of that disturbance is actually the wave. It is known that mechanical waves, they need a medium to propagate or to move. You need a medium to produce a wave. First of all, you need the source of the disturbance, and you need a medium where this disturbance is going to move. That's for mechanical waves. However, let me give you an example of mechanical wave. Mechanical wave will be a sound wave. Sound wave is a mechanical wave. So what is the source? The source are your vocal cords, and the medium will be the air between me and you. So you will receive the sound in your ear, and then the medium is the air. The air particles are going to transmit the sound wave. Another type of mechanical wave will be the wave on a string, and this is we will see this in this course. The other type of mechanical of waves in general are the electromagnetic waves. And electromagnetic waves, they don't need a medium actually. They can travel in vacuum even. Examples will be light, microwave, X-rays, gamma rays. All of them, all these, they don't need actually a medium. Actually, we receive the light from the sun, and we know that outer space there are no air molecules. There is no medium, and vacuum is vacuum, and we receive light from the sun, and therefore the electromagnetic waves, they don't need actually a medium, and they travel at a constant speed, which is the speed of light, which is 3×10⁸ meters per second. This is the second type. We're not going to study this type of waves. Our focus in this course are about mechanical waves, but I'm just giving you an overview about the type of waves. The third type of waves are the matter waves. Later, maybe somehow in your educational life here at Ethiopia, you might go through the concepts of matter waves, where matter can behave as a wave. Electrons are very well known that electrons can behave as waves, and this is what we call matter waves. So we are going to concentrate now on mechanical waves, okay? So mechanical waves, as we said, they need a medium, okay? Mechanical waves. So mechanical waves, they need a medium to propagate, and there should be a source of the disturbance, because actually waves is a motion of a disturbance. There are two types of mechanical waves. Two types. Okay? We have what we call longitudinal wave. Okay? And we have what we call transverse. Longitudinal wave, an example of longitudinal wave will be sound waves. Okay? Sound waves. Sound waves, they need a medium, and they need the source of the disturbance. And an example of transverse wave will be waves on strings. Wave on a string. Okay. Now let me give you let me show the difference between transverse and longitudinal wave. As you can see here in this animation, we have the source of the disturbance is here, and my medium is this string here. Imagine that this is a string. Okay. And now we are going to start moving up and down to produce the wave. So the disturbance now is producing a wave. As you can see, the wave now is moving to the right. As you can see, this wave is moving to the right. So the wave has a direction, because it is moving. So we say moving to the right or to the left. Now you can see, if you look at this point here, the maximum point, you can see it is moving to the right. And we notice something very important, that it is moving at a constant rate. So the velocity or the speed of this wave is constant. You can see it. It's not accelerating this wave, okay? So the wave is moving at a constant speed. The other motion that we have to take care of is the motion of the particles of the medium. And as you can see, let's take this point here, the green point, is moving up and down, as you can see. All these points here, they are moving up and down. The points that makes the medium, they are moving up and down, and the wave is moving to the right. So what is the angle between the two motions? The two motions are perpendicular, okay? So wave on the string, transverse wave, the motion, we say that the motion of the wave, okay, and the motion of the particles are perpendicular. Particles are perpendicular. When these two motions are perpendicular, we call this a transverse waves. Okay, the motion of the particle. So to know do we have a transverse or longitudinal wave, we have to look at the two motions. So we have two motions. We have the motion of the wave and the motion of the particle, which are making the medium of this where the wave is propagating or moving. Okay. So when these two motions are perpendicular, we call this transverse wave. Now I'm going to show you now longitudinal waves. Okay, where and you will see the difference between these two. Now this is air molecules, and there is a piston here. It's not shown. There's a piston here, as you can see. It is the disturbance is this piston here, which is moving left and right. Okay, so it's pushing on the air particles, and these air particles, you have to be careful. They are not moving in this direction, the air particles. If you concentrate on one, so you have if you look at this part here, it's moving to the right. It means the wave is moving to the right. You can see. If you look at carefully, yeah? Now, let's look at one particle here, specific particle, the red one here. How is its motion? You can see that it's moving left and right. It's oscillating, just like before, the particle there were oscillating up and down. Now the particle here is oscillating left and right, and the wave is moving to the right. Okay? So you can see here the wave. The black arrow is showing the motion of the wave. This arrow here is showing the motion of the particle, and you can see the particle is oscillating about an equilibrium point. Okay, it's oscillating right and left. So the motion of the wave is to the right, and the particle is moving right and left. So how are these two motions? They are parallel. Okay, so longitudinal wave, we have the motion of the wave. Okay, and the motion of the particles. So be careful, you have two motions. The motion of the particles making the medium particles are parallel. So the key word here is the parallel and the perpendicular here. So if the motion of the particle and the motion of the wave are perpendicular, we call them transverse waves. An example are the wave on the string. If the motion of the particle and the motion of the waves are parallel, we say this longitudinal wave. An example are sound waves. Thank you.